Oh, there we go. Does this work now? This is what I get for setting everything up the day before and testing. Testing, testing, 1, 2, 3. Testing, testing, 1, 2, 3. Sounds like the audio is still too low. Let's jack that up a bit. Hopefully this doesn't blow out everyone's ears. Okay, no, we're doing good now. Oh, there's also a separate. Is this also adjusting the volume? No. Gain. Oh, gain. There we go. There we go. Testing. Testing. Gain. Oh, gain. There we go. Bit more gain. Bit more gain. There we go. There we go. Ah, finally. Yeah, man. I thought I had all this working. Is the volume okay for you? Bit more gain. There we go. Ah, finally. Yeah, man. I thought I had all this working. Is the volume okay for you? Ah, finally. Yeah, man. I thought I had all this working. Yeah, La Rubel, I think you're the only one here right now. Thanks for joining. I had a couple other people interested, but the time, the notice was a bit short and the time is a bit awkward. So some people might jump in later if they're still like driving home from work. I still need to figure out thanks for joining. Why I can hear myself. Oh, here we go. Perfect. I had a YouTube tab open. So I have this on Discord, YouTube, and Twitch. Links in the channel description for all of the above. Just gonna see if I can pop out chat. YouTube chat is the most broken thing I've ever had to deal with. I spent way too much time getting that to work, and I still let's see if I can get the chat, which I need to interact. There we go. This should have automatically logged into all of them. Nope, it didn't. You lost all of the settings. Great. Okay. Perfect. Great start. You're having a video error on Discord. Is Discord's image flipped? Like, is the writing backwards right now? Because as far as I can see on Discord, it's flipped my image, but I don't know if that's just my end. Oh, you have no video. I'm definitely sending video. Yeah, 65 milliseconds, sending video, everything looks good. Oh, like that. You shouldn't be able to start a camera in a stage. I don't think you can actually share video on your end. A Discord stage is a bit different than a normal Discord channel. But that looks like, oh, it's on my video feed. Okay, that's interesting. I hope that's just you. I mean, I hope it's an issue that can be resolved, but hopefully it's not like some catastrophic thing with like Discord or something. Um, Let me just fix the chat integration here and we'll get a bit more on topic. So I did something incredibly stupid and I rolled my own chat overlay for OBS that is able to integrate the chats of all three services, or more if I really want to. And so I have tested it, but it's yeah. The man, and once again, YouTube was the worst part. Like it took me 2 days to write this thing, and then it took me 6 months of dealing with YouTube to get the API quota, like query limit, raised so that I could receive messages faster than once every 10 seconds from their API. And that was just the worst process. It's yeah, it was hair pulling. I'm pretty sure the first like long bit of it was just me talking to a bot, like an AI, and then finally after I hit the magic words, yeah, I like typed. I actually started like I got really suspicious, so I started like trying to put like prompts in and this is on via email, and so I started putting like prompts that were worded just well enough that it would reveal if it was an AI, but not like confusing if it wasn't an AI. And I'm so sure it was an AI. The yeah, just the logic that it was sending me through. It was just circles after circles. Link. Channel ID. There it is. Hopefully, I don't reveal anything with this. And let me test YouTube and Twitch. This one's working. God, I like how I have to approve my own. Okay, so that just didn't work. I'm gonna hide this real quick. Okay, that's reassuring. Hmm. Oops. I think it breaks when I hide it. OBS, yeah, come on, OBS. You can do better. There we go. There we go. And one more time for Twitch. That's logged in supposedly. Let's check. Ah, yes. Okay, now let's try Twitch. We can do this. We have the technology. I swear this was all working before. Twitch works. Now Discord. Yeah, no worries. Of course, Discord doesn't work. Why does Discord not work? One viewer. Oh, cool. Do I have a viewer in Twitch? Hey there. Yeah, I'm just trying to get this started. This is like the maiden voyage of this whole stream here, and a couple things decided to blow up at the last second. Bear with me while I just tweak some settings in OBS. I promise this will get interesting real quick. Just need to enter some passwords here that looks like my sessions have expired on the chat. Okay. All right, that's good to go. Oh yeah, man, Discord. I was really torn about even doing this on Discord just because of like I've been hating it for a while now, and it's like I don't know, hasn't been getting any better. But it's the only ad-free one, so I figured I might as well do it. There was also a community of people on it. Oh, I see what's wrong with Discord. Okay, give me another second here. At least the Discord chat. All of my sessions have expired, which means I have to relog in. Should have lasted longer, but it didn't. Yeah. They're supposed to last like a week, but it just I don't know. Had other opinions. Okay. Application ID there, and reset token. Yeah. I'll have to remember to do this beforehand. Discord's also problematic because it doesn't provide an API for accessing the chats. You literally have to create a one-off bot. And then have the bot join the channel and then suck the chat history out by that. And then OBS. Let's just move that away. Chat, interact, instructions. There. And there. And I really don't want to have to just discard the chat overlay. That was like gonna be good. But OBS is being dumb. And then yeah, just throw it out and get started. Let's see if I just need to swap the scenes. There we go. And then, does it work? Ha! We have Discord. All right. And great. Okay. I was hoping for a couple more people, but this is cozy. Today I'm just going to go into like some introductory stuff, kind of talk about what my plans actually are with this whole thing, make sure people are actually interested in it. And gonna compile the kernel. That's gonna be riveting. And yeah, just kind of discuss some stuff. Here, let me get to the main scene here. Oh, and nope, we're not gonna do that yet. My camera. I'm using my phone as my camera, and I needed my authenticator app, so my camera needs to be reset up. One moment. Are we good? Almost good. How we doing now? Oh yeah. Oh, minor alignment issue. Watch the whole thing like jump or fall over. There we go. Yeah, I know. It's like you want a high quality image without having to pay any money. Usually the webcam on built into like your laptop or whatever is a bit of a potato. You can buy those high definition dedicated webcams, but I didn't want to do that. So there's this really awesome app that's free on Android called Cam On. And it basically just sets up your phone as a RTSP server. And then OBS just connects to that and sucks the video feed in. It was so painless. And because Android allows you to tether a network connection through the USB cable, it's all wired and high speed and no serious bottlenecks. And yeah, that had to have been the easiest part of this whole process. If you ever want to do something like that, definitely recommend checking out that app. So we have OBS shut down on start streaming. There we go. So I'm running this whole thing inside of a VM just so I don't have to nuke or accidentally dox myself on my main computer. Let me just get my hair back here. I was playing with this just a second ago because the lighting changed. Hey, I'm not bald. Awesome. Is it causing any? Nope. Okay. Good stuff. Yeah. I have like a scratch pad that I've uploaded to the internet, to my blog. It's going to be reorganized as like something a lot more coherent later on, but for right now, that's what it is. And I'm going to dump the link in. Yeah, gray early. No, I like my hair. I want to keep it. And just dump the link into, man, YouTube's. There we go. Nope, that is not. Where is it? Apparently, I'm going to keep doing this too. I can copy into the VM, but not out of the VM because there's some weird X11 bug that's going on with Virtual Machine Manager. I just want to dump the link to this scratch on my blog into the chat so that you can like have a look at it if you want. And then I don't have to constantly dump links that I'm copying out of it. There we go. I'm just using Linux's Virtual Machine Manager. Is literally the name of the program. It's simple and does the job. And then inside of it, I just have like a very basic Ubuntu, KDE Ubuntu. And Discord and Twitch chats. One thing that I definitely need to do with this chat stream thing is make it so that I can just post to all of the platforms at the same time, but I only really wanted it for the overlay, and so I didn't implement posting yet. That gets a lot more complicated with the different APIs. Okay. So I guess I'll go into why I'm doing this. I think I mentioned it when I was posting around to all over the places that I've been using Linux for like 15 years, and I've been kind of piecing together an understanding of it, and I've kind of hit a critical mass in my understanding of the different like subsystems and whatnot. And so I kind of want to just kind of systematically go through each and every bit of Linux and just fill in all of these gaps. It's a bit exhaustive, but I figured while I was doing that, I might as well produce something out of it. And I have a laundry list of things I want in Linux in my desktop environment that just don't exist. And and then when I was thinking, I was like, oh man, maybe other people would be interested in following along on this. Also, if it would be really cool to get like feedback and input on during the process. If there's people who know better or have questions or point something out, or generally, yeah, just want to make this process a little less tedious. Yeah, I gotta. Probably, I should probably add a 50% grade to the background, eh? Luckily, I can do that very quickly. Let me chat background color, RGB. Where's the color picker? Okay. Let me see if this fixes it for you. 80, 90, 90, 90. Let's set it at 30% opacity. %, opacity. I don't know how that came out green. Oh, that's why. Adjust that later. Let's get rid of the crazy background. Oh, and I guess it refreshes it every time I change the settings. Oh yeah, thanks. So yeah, I guess back to the project. Um, the What I'm imagining is um, just to. So I do want to keep the stream at least accessible to people who are new to Linux. So I might go on a brief little tangent with some like very basic background information. Um, but I am recording this for a VOD later on. I'd like to just get the maximum out of it. So the idea behind it is that I want the most Linux operating systems boot an initial mini operating system, the init ramfs, and then immediately drops it. After it loads or after it mounts the hard drive and remounts, and then loads up the rest of the operating system. I want to skip that step for several reasons. I want the core operating system to be immutable, but not necessarily in the way that I know a lot of distributions have started throwing around the word immutable, but they are still sometimes mutable. The idea is that the components, the core of it, would be signed or hashed at build time, and it wouldn't change. So if an end user installs software, nothing is changing, which means it's completely reproducible on any system. Which makes like support a lot easier because you know exactly what someone's booting based on the hash that they downloaded, and it also gives you like very well defined systems. There's no patch version that may vary between things. Like you're dealing with hashes. You can, like some systems, use something called DM Verity, which makes things immutable until you unlock the Verity and start mutating it. And that hash depends on the, for the most part, depends on that is determined at installation time rather than build time. Whereas the hash is determined at build time. And then from there, one thing that's always bothered me about Linux operating systems is that the package managers and just the whole system operate off of a single file system. The like it just dumps everything into one bucket. Yeah, yeah, I know. I was really surprised when I started hearing other like projects throw this term around because I'm like, oh wow, that's a great direction to go in. And then I saw how they were doing it, and I was like, oh no, that's like it misses the point. Like it's good immutable for like security and preventing users from breaking things, but it the whole point of like the major benefit of immutability is that everyone's the same, and if you're mutating even some privileged process is even if some privileged highly orchestrated process is mutating it on the system, then it's not like you lose the benefit of it. So I definitely want to not do that. I want to make it immutable at build time. The Linux kernel does a good job of this, where it will report that it has been tainted if you well, not only will it report if it's tainted by loading kernel modules that it's not familiar with, but it will report if it has been built, like if it's a custom build or if it's a build from some like known distribution. So at least the kernel devs know if you've been messing with the kernel and asking for support on some modified kernel, and they'll just be like, "No, you're doing something weird. Like you got to figure it out." But I want that for an entire operating system. The other thing is like I was mentioning about the file system is the package managers dump everything. Yeah, most yeah, much less useful. Yeah, exactly. And so the package managers, they dump everything into a single directory structure. Like all of the libraries go in user lib, all of the binaries go into user bin or whatever. And then you got multiple different locations that things get stuck. You install a program and it shotguns files at your entire file system. And then you want to like, and then something, it changes something unexpectedly and it impacts another program running somewhere else, or you want to uninstall it and it doesn't fully carve itself out of your system. And I've just always hated that. Like you go and like I've had it in the past where I go and install some dumb little program where I'm like, oh, okay, like let's just check this out, and the installation process like bundles a pre-built library that overwrites a main library, just like it's a poorly built package. And then it just nukes my entire system, and I can't figure out why other things have changed, like the behavior has changed. And it was a very hair pulling process. I think I lost like 2 weeks of that before I just wiped everything and started over, which is always audio got very quiet. Uh, I think I'm okay on my end. The bars are where they should be. Uh, yeah, nothing changed. I can turn it up if it's actually a problem, especially on Discord. Oh, actually, maybe not on Discord. Let's. Now I'm gonna fight this VM. It's, all right. screen on my primary desktop, so I have to like minimize it, which is it tries to capture the controls when I do that. Oh, yeah, what the heck is that? Something auto leveled my microphone. Ah, is that Discord? Discord, are you messing with my sound settings? Do not automatically adjust my sound settings. Do not automatically determine input sensitivity. Yeah, once again, Discord, ruining it for everyone. Okay, is that better? Hopefully that doesn't, I didn't just blow out everyone's ears. Let me get back to the chat. Yeah, anyway, back to Linux generally having a single file system. So there are, I mean, there's this concept of containerization. Oh shit, okay. But is it a good volume now? Okay, good. All right. How do I keep losing chat? There we go. Yeah, I'm noticing that. The delay on every platform is different. Even the delay between my VM and my main desktop is a little bit trippy. It's got like a half a second delay. The Anyway, back to the file systems. So Linux has this concept of containerization. Docker is one product in that space. And it's certainly not new. Especially like desktop applications being containerized, you'll find things like Flatpak that are trying to go that direction. Huh. Yeah, I guess it makes sense that Discord's faster with the stream because I think isn't Discord still peer to peer or are they going through? Uh, anyway, like I mentioned, Flatpak and whatnot, where you will have an application that gets its own entire directory structure with all its own files, and that's completely separate from every other application. Um, and I want to go in that direction, but Flatpak has some issues that I don't think are resolvable. It's kind of core to its design, so I don't know if I actually want to use the Flatpak runtime for any of this. The other thing is I really want to take it to an extreme where the basically the entire system is run in containers. You have the core boot. It's called a UKI, Universal Kernel, or Unified Kernel Image. That allows you to load a complete operating system into a single file that the computer will boot. And then from there, everything that will bootstrap containers for the rest of the systems. And so it's a matter of figuring out where to draw the line between what to put inside the UKI and what to put inside the rest of the containers. What this will do is it gets a lot of benefits outside of keeping the file system separate so the programs don't interfere with each other. You get because you're using containers basically in like an OCI container, which is a standard. You can sign these containers, and the containers are hashed, so they are immutable. and having the UKI bootstrap these containers, what you can do is it changes the way that Linux is installed. Because the UKI is a single file and it's booted directly, what you don't need to repartition your disk to install Linux. You can actually have, like, you can use the Windows file system to install and have Linux run on top of that. The UKI gets written to a special section of your hard drive called the boot partition. And it doesn't matter if you're running Windows, it doesn't matter if you're running Linux. This boot partition exists. It's part of your computer's firmware standard, where it will look for this partition to find what operating system to boot. The computer firmware standard that most computers have these days is called UEFI. On mobile devices, they have a very cut down version of this called U-Boot, but it's UEFI but with less features. And so when your computer turns on, the firmware kicks in, the UEFI firmware, and then it looks at some settings that's stored on your motherboard, not on any hard drive or anything like that, on where to boot, and then from there it finds this section of your disk and then finds the file within it, the UKI or the Windows boot manager or whatever, and kicks that off and your whole operating system pops up on your screen. And so what you can do is if you drop this file into the boot partition, and there's, normally you want to keep these files pretty small, because it has to copy the entire thing into memory. But there's tricks you can do to make that not a problem. So you can actually have a larger one with enough of an operating system. So all of the core systems, and enough code that it can prompt you to like log in, pick, and like download and bootstrap containers. So you can, like normally when you install Linux, you have to flash an ISO to a USB stick, reboot, plug that in, hopefully everything works. Driver-wise, you have the whole live CD experience, then you have to tell it to install. And then it like downloads a bunch of packages. It asks you to like set up its own partition, this whole mess, loads in all the packages. Twitch is not showing up in the chat overlay. Why is Twitch not showing up in the chat overlay? It was working a moment ago. Come on, Twitch. Don't tell me your token expires within minutes. I did not have that before. Yeah. Whoop, caps lock. So I just had it work. Hold on. Don't tell me there's like some weird timeout on Twitch's API. Let's do that. So Twitch chat, Twitch chat's just not working. Well, oh no, okay. Twitch chat's working over here. I think this is an issue. Something's going on with OBS's chat overlay. So I actually can open this. I have the chat overlay open in a separate browser window because that's all this chat is a browser. And I can see your messages there. There's something going on with, oh, apparently hiding it refreshes the page. It's not actually an Electron app. It's actually just a web browser. It's literally just Chrome. Yeah, like a headless Chrome that it like sucks the video frames out of. All right, there we go. Now it looks like it's working again. Yeah, this chat client is entirely just client-side web browser JavaScript fun, and it just talks directly to the APIs. That's the other. There are other like offerings of this kind of product that they're all services though. They require a server-side thing, which I didn't want to. I mean, it was easier to just write my own than pay for it. Gonna have to figure out what's up with these instability issues though. Yeah, there's something wrong with the Twitch socket. Yeah, I do have messages that, like, I do have it set up so that the messages slowly scroll off screen. I might want to disable that. It was more just to keep the screen clear on the video overlay. Is that quick and dirty to disable? I have it configurable. I just don't remember how to do that. Instructions. Oh, literally just set the speed to 0. All right, let me fix that. There. When I built this, I was testing for a much more active chat. And I noticed that the screen was always just flooded. So I added this feature where it would always just scroll off the older message. Thank you. Although it looks like the Twitch So, unless you get up to like 1,000 messages per minute, I was aiming for people just vomiting emojis into it. It's also missing messages. I don't know. I'm gonna give up on this chat overlay for now. Um, and of course, I just kicked my tripod. Next time, then tomorrow, much higher production quality. I promise. Man, I'm gonna have to spend a lot more effort on this chat stream. Yeah, debugging it's going to be fairly simple. I just need to like get quiet for a minute and like actually go into the debug log. But I don't think you want to watch me just sit here and like stare at the screen for an hour. Where did I leave off? I lost my train of thought. Are you following what I was talking about? I'm talking pretty high level right now. As far as the recording goes, if anyone feels lost, don't worry. I'm going to get real into everything I just mentioned. Actually, maybe we should just get right to it, and circle back later on some of these design plans. Yeah, some of these are much more kind of advanced concepts that I don't think are readily accessible without building up a lot of context beforehand. Oh, that's cool. But yeah, let me kind of get into this here, and I'll show you what I mean by the kernel and whatnot. This is from yesterday. I was doing a bit of prep, just making sure that that this was like somewhat ready, even though I'm having a rough time with the OBS stream. So you want to so basically, I guess the first question is what the heck is Linux? And it all kind of starts with the Linux kernel. Linux is essentially the Linux kernel, and then built on top of that is a more complete operating system, but those are provided by other groups. You may have heard of GNU Linux. People like being like, oh, don't call it Linux, call it GNU Linux, GNU Linux. And that's because there's the group called GNU. I think it's literally just .nu.org. And they, unless this isn't actually. How to manage that? Oh, it is new.org. So I guess their website's having issues. Anyway, I just wanted to really just show you this bull, or this yak, I think is what it is. So this group, they produce everything that you directly interact with Linux. Um, like if you're, at least on the command line, the most notable thing that they produce is a package of utilities called, or programs called core utils. Without those, oh, it's called a new. Okay. Uh, they produce a package called core utils, and without that, you would not be able to use it would Linux would just do a quick thing. Oh, I can show you. It'll do a quick thing on your screen, and then be like, don't know what to do now because I'm only running the hardware. I provide no real user interface. Um, so here I had this prepared. So basically, let's eliminate this. So what you're seeing on the screen right now is basically a virtual computer, an emulated computer starting up, and all this text that's scrolling by is the Linux kernel saying what it's doing. Oh, and it's still found. It still found the init. So the Linux kernel itself basically gets all your hardware ready to be run and manages the hardware directly. So like you can see, like this is a lot of unintelligible stuff unless you really understand, like know its internals. But for the most part, it's just setting up your RAM, setting up some of the motherboard's communication buses, sets up ACPI, which is your computer's, the way your CPU talks to the rest of the computer and the hardware. ACPI has a bunch of information that the kernel has to load out of your firmware. More setting up stuff. Then the kernel has a good look at your CPU to see what it is and what it can do. And then it gets into loading all of the different modules that the kernel has to manage each different bit of hardware, and on and on. PCI bus, lots of networking stuff, just stuff you don't directly interact with, but needs to work in order for the software on your computer to be able to run and access all of your hardware. Oh, got a couple more viewers on Twitch. Cool. And once we get through all of the system setup, it gets to, I was actually trying to make that fail. Let's see if I can get that to fail. Let's, so oh, that's why I didn't fail before. So I'm just restarting the kernel. Once again, this is what you would normally see on your screen when your computer first starts up. But because I'm running basically a virtual computer inside my computer, you're just seeing it inside this box. And then, yeah, so it gets down here, and it's the kernel. The last thing the kernel does is once it sets everything up, it tries to look for a program to start. And it tries to find that program on a disk somewhere. And in this case, it couldn't find it and freaks out, panics, and shoots itself in the head. Uh, and because the kernel doesn't provide you any sort of interface, there's nothing you can interact with. From there, you need to give it something to actually start a first program, an initial program, if you will. So just to explain a little bit about, whoops, that's right. There we go. A little bit about this. If you've never encountered, just a little bit for the newbies, you may have seen that Linux has a command line. Windows has a command line too, but you're going to interact with it a lot more with Linux just because Windows tries to put just about everything and make it available in like a GUI with like system settings and stuff. But the Linux is more, because all of the different components are provided by different people and groups and whatnot, it's kind of a little bit more difficult to make it cohesive in a UI. That a lot of effort has gone into it, but it's never 100% like Windows. So a lot of stuff gets put into the command line. And this is literally just a program that allows you to type commands, and just to like vaguely go over it, when a command is a program's name, in this case, this program right here is the virtual computer that I'm using, or an emulator, if you're familiar with like video game emulators. Like if you're trying to run, there's like emulators that allow you to run like PlayStation games on your PC or Nintendo games on your cell phone. You can get an emulator program. This is exactly that, but it emulates a desktop PC. And then, so it's the name of the program, and then a bunch of arguments, or a bunch of like settings for that program to use when it runs. Every program has different settings. There's no real point in trying to memorize all of this. You just go and look up the documentation for the program when you want to use it. And if you use it a lot, you'll remember it. But anyway, for this particular program, I'm giving it basically, when it panicked because it couldn't find the boot, like the initial program, it couldn't find the disk or the initial program. Now I'm essentially giving it that. This little init.rd cpio is a file that contains basically a disk. It's like a disk that contains the program. And when I give it that, the Linux kernel starts up and then sets everything up, looks for this initial program, and starts it. Eventually, there we go. And you can see, just like here, this is outside of that virtual computer. It's a little command line you can type commands into. There's not much that can be done inside this computer right now because there's only one program, and it's called Toybox. I mentioned, and I'm talking about this because I mentioned new, get back here. New produces a suite called Core Utils. It's a very large, very robust suite that allows you to do a lot of things in terms of managing your computer, manipulating things inside your computer, but it's big. And so some alternatives have been produced over the years. Some people may be familiar with something called BusyBox, where they take all of those utilities and put it inside of a single program that you can run, and it's just a different way of interacting with it. Unfortunately, BusyBox has some licensing issues, and they have been known to actually sue people for using their program in certain places. So an alternative to that was produced called Toybox. And so Toybox gives me commands like ls which lists all the files in a folder. And you'll be seeing me use these a lot all over the place. Core Utils also provides these programs with the same name and same parameters. There's actually a standard for these, and they should be pretty uniform across all Linux environments. If you're using a Mac, this is also available, but Mac has its own implementation with its own arguments. So they're similar, but not same enough for you to comfortably switch just between a Mac's command line and Linux command line. But anyway, this initial program here is giving me a command line, but on a normal desktop, much more happens. The Linux kernel, so you want like a full user interface with like start menu and maybe a login screen, and maybe extra things need to be set up. You want to do more configuration than just start up all your hardware. And so the initial program, there's a few different versions that have been built over the years, is generally responsible for orchestrating, setting up everything beyond just what the kernel does. But that's getting a little bit ahead of things. Today, I just want to look at how do you get the kernel, and what does it take to actually compile it. So you can download the kernel pre-compiled, so it's just an executable, but there's a lot of options that come with the kernel, and you may want to change something. Different decisions are being made in these options on how the system functions and what features are available, and a variety of things. Where'd it go? First thing you want to do is where is this? So the Linux kernel was produced by a guy named Linus Torvalds. May have heard of him. He's a little bit famous in the nerd space. Here, I got a photo of him that's hilarious. He's known for, where did it go? He's known for his, Linux is famous because it has been very reliable over the years, especially in like the internet runs on Linux. And this is largely due in part because console argument stands for it. Oh yeah, the Linux, that's the one thing about Linux and its reliability is it works with hardware all the way back to like the 70s, and it still does. It's crazy. You can install this on absolutely ancient hardware. Like we're talking hardware that doesn't even have a computer screen. It like Laura Rubel mentioned, it has like a printer. So instead of like text scrolling down on the screen here, it would literally be printed line by line on a printer, and then you'd tear off the paper, look at it, and then type some more things into your keyboard, and then it would print some more. It was such a tremendous waste of paper, but they weren't quite working at the same pace as you do on a modern computer. And because of that, it's become a typewriter. Sorry, I was trying to avoid that because I guarantee people aren't even familiar with like what the heck is a typewriter kind of thing. Can I get a photo of a teletypewriter? You can still find these in you can find these for deaf people. They can, yeah, something like this is still available, because you can basically send text over landlines. But you would probably be working with something like this. And literally the instead of the text showing up on a screen, it would be written out on that paper, and then you would type some more stuff in. And Linux continues to be able to work with hardware like this, even though it's absolutely ancient. But yeah, like I said, reliability. Typewriter. Sorry, that's a yeah, like a thing with little metal things that go clack, 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 clack. Like you see in old timey stuff in videos or movies. Where was I here? I need a third monitor is what I need. Oh, did you switch back to YouTube? Oh, we're back to Discord. Okay. Well, looks like Discord chat's working. But for chat only? Okay. Yeah, okay. The Anyways, like I said, Linus Torvalds. One of the reasons Linux has been so reliable is because this guy has like strong, very well-formed opinions on the way things should be. And so after he initially wrote Linux, he made it public, and he has guided its development. A lot of people have contributed to the project since then. And for the most part, he doesn't even write code anymore. He just maintains standards and reviews all of the code that's being contributed towards Linux. But he has high bars, higher than most other projects. That he could have improved things like standards for documentation and stuff like that. But he has certain things that he feels strongly about. And yeah, so this famously is a photo of him. Acerbic? I gotta look that word up. But yeah, he is strong-willed, and he has held such a high standard of reliability for Linux, particularly. He makes sure that things do not break when new features are released or changes are released. And this is him flipping off NVIDIA because they are absolutely horrendous for supporting drivers in the Linux space, and it's like they go out of their way to make it difficult for Linux to support NVIDIA graphics cards. Of course, in the last couple of years, that's changed where they have released an open source driver. It's not quite finished yet, but it's getting there, hopefully. And the only reason I think they did that, the only reason I think that NVIDIA even did that was just because of AI and companies wanting to run or utilize NVIDIA cards on servers running Linux, and they couldn't keep the drivers moving fast enough to keep them closed sourced, so they open sourced them just to probably for a variety of political reasons. But I guess that's one good thing that came out of AI is NVIDIA being compelled to open source their drivers, I'm assuming. But anyway, that guy also, supposedly he's actually more famous for producing Git, which is a program that manages and versions files. If like, you know, I don't know if you ever used Google Docs, how you can go into and look at the change history for the document if you're editing it, especially like with other people. Git does sort of the same thing, where it keeps a history of the changes. And this is really useful for tracking source code and changes to source code. And way back when Linus was writing Linux, he needed to 1597. Okay, let's look. What is 1597? Where am I here? Oh yeah, okay, here we go. Yeah, yeah. Git, man, I almost want to do like not today, but a little tutorial on Git. The way people think about Git has always surprised me because it's such a simple program. That what it does is so simple, but people get so confused by it so quickly just because of like I've never actually seen a proper description of the flow of what Git is doing to the files that it's tracking. Anyway, so he produced Git. Supposedly, he's actually more famous for Git than Linux, which surprises people. But Git is used more generally by programmers, whereas Linux, the only time you directly interact with Linux is if you're building a distribution or you're a system administrator. So he produced Git to track Linux code, and so if you want to compile the Linux kernel, you, for the most part, want to download it using Git. Oops, that's right. Running the virtual machine always corrupts the terminal's text. And so what you do is you use the Git program that you would have to install. Oh, cool. Yeah, you can link to it if you want. Um, where you run the Git program, tell it to clone the remote source code, which is stored at this URL. Oops. So I actually learned something setting this up. I have always assumed that the official repository for Linux, that everything is like built and released from, was specifically Linus's copy of it. But it's not. There's actually an official repository that's literally yeah, it's literally like instead of Linux kernel get Torvalds, it's Linux kernel get stable, which is a separate repository that it looks like Greg Crow Hartman. I gotta admit, I'm not terribly familiar with all the people in the Linux space, but he's looks like he's important. Releases, and it's probably not a big deal that I was pulling Linus's version of it because it's probably very close to the official release because he kind of has like the signing authority for the changes that are released. So in this example, I pulled down Linus's, but you would probably want to pull down the proper one. This is available at kernel.org, of course. You can just directly download a tarball, or you can go to the actual Git repository browser and get the latest release. Yeah, I think you just, am I wrong? Is this the URL I want? You would have to delete this. Yeah, just like that. So you would git clone. And if you're going to clone it, just to be a good Samaritan, make sure you specify depth 1 if you're trying to follow along. When you clone a repository, it will download the entire change history, which is enormous. And you don't want to like create that kind of traffic on the official Git server. So if you want to just get the most recent copy of the code at commit or at tag version 6.18. Although if you were not pulling from Linus's, you'd want 6.18y. I hope this text isn't too small in the browser, now that I think of it. It's probably better. So that's the tag you should pull from the main repository. So it would be git clone depth1, pick the tag version 6.18y, this URL. And what it'll do is whatever folder you're currently in, it will create another folder by this name and download all of the source code to it. I've already done this. I think I just accidentally hit the mute button on my microphone. Anyway, yeah, I don't think I would want to try and download the full Linux history. That would be time consuming at very least. So anyway, here's all the source code. There's a medium amount of documentation. Could always be better, but that's generally true. And then there's a bunch of extra stuff like is the firmware included in here? I think that's a separate repository. Different modules, like you have like all of the different drivers that have been implemented. Unlike Windows, where you generally have to have the drivers provided by third parties, Windows does bundle drivers, some of them, I believe. Linux is a bit different in that drivers, for the most part, there are always exceptions. Linux comes with like packages all of the drivers for all of the hardware that you could almost ever encounter in itself. This is why Linux is often seen as having better hardware support than Windows for things, especially older hardware. Windows drops support for printers all the time, whereas Linux, there's drivers in here I'm sure there's a driver in here for a teletype typewriter. I don't know. I've never really looked into it, but this is one of the main benefits of Linux is just hardware support going all the way back. But for the most part, you probably don't want to get into the source code of Linux. You just want to boot it. So there's a few steps you have to do. If you're compiling Linux on a Debian-based system, you will need to install some build dependencies. Aptitude is the command line software package installer manager that installs on a Linux system. I can't imagine compiling Linux on a Windows system. That never even occurred to me. I wouldn't know how to do that. You'd probably have to start up a Linux VM or something. Don't know. It has a feature called build dep. You can tell it to install the build dependencies for Linux. You also need to install some programs for the build chain and whatnot. There's some tools that also are bundled with Linux that require some libraries. I've already installed those, so don't need to go through that. And then for the kernel build, uh, they've actually provided a pretty robust configuration and build system for the Linux kernel. One program when you're, I I'm pretty sure Bison I've used. Flex I'm not terribly familiar with. The Linux is written in C, and I I don't know if I've really used C that much. I have always used C++, which is different enough that the tooling is a bit confusing for C for me. I'm very familiar, I'm familiar with the tool make, which is about C. I have reservations for C. So I always thought that C++ was, I mean, it is a superset of C. For the most part, there's some things that won't compile directly between the other them, but C is way more limited than I thought it is. You can't override operators in C. There was a few other things that you couldn't do in C. I mean, you can't template functions. Anyways, I tried to learn a little bit more about C, and I just saw some of the features that were missing from it, and I'm just like, oh no, I'm going to stick with C++. But anyways, Linux is written in C, and C is universal assembly. Yeah, it's, I mean, it's simple, I guess, but it's so simple it forces you to manipulate memory directly, which is why Rust has so much popularity. If they implemented operator overloading, you could get away from manipulating memory directly a lot easier. Anyway, that's a whole nother thing. Just by like wrapping a lot of the logic in operators rather than having to do pointer arithmetic. Back to compiling Linux C code though. The main program that you interact with when compiling, at least Linux, is make. Make is responsible for going through, like it orchestrates the compilation. GCC is the actual compiler that turns the written human readable code into computer readable code. But you need like a whole harness around that to set up the configuration, make sure everything's where it needs to be, figuring out if anything has already been compiled, if anything needs to be cleaned up, just everything that needs to be done before and after actually compiling the code, make orchestrates. And make allows the person who wrote the code to provide useful little shortcuts, I guess. I don't know really how to describe it. It's not code. It's not a script. It's a build target. Provide custom build targets that allow you to do useful things other than building the program, like make help. Whoops. Not like make help because I'm not in the Linux repository. Let's try that again. So make help vomits out a whole bunch of text that tells you all of the different ways that you can compile the kernel. So if you type make clean, it'll delete all of the builds. Like if you'd compiled, you can already, but you want to change something or something went wrong, you want to redo it, you can go make clean. It'll delete everything and prepare it to be rebuilt. But the most notable ones that we want to look at is the configuration targets. Linux has a million little knobs and dials that you can set at compile time that will change things drastically. You may have encountered Linux distributions that say they're highly optimized. And a big part of that is someone has gone through all of the Linux configuration knobs and dials and like tuned them for whatever they're aiming for. There's no perfect configuration because there are different applications. You could be running it on a server, you could be running it for gaming, you could be running it for embedded. There's so many different ways that you can configure Linux for different things that that they went out of their way to produce a system to help you configure Linux. And they provide a couple of defaults. So tinyconfig, if you ever wanted to play with it, it's kind of interesting. It makes Linux as small as it possibly can be with almost no hardware support. This is really useful for embedded. It's a starting point for if you want to put Linux on a microcontroller like Raspberry Pi or something like that. And then there's the default configuration. This is really useful if you just want to compile Linux on for a desktop computer or a server and just want to take like the most obvious settings without really thinking about it. And it'll automatically just assume that you're compiling the kernel for the computer that it's being compiled on. Because you can compile the kernel for, like, I'm running an x86 computer, but you may have heard of ARM. Mac is using ARM processors now. It's just a different kind of hardware, and you can't run software that was compiled for ARM on an x86 and vice versa. Yeah, cross compilation gets there's some people have done great work in making it easy for things like if you write code in Golang, the Go developers put a lot of effort into making cross compilation of Go code very easy. I'm sure there's suites of tools for other languages. I've avoided cross compilation. I've never really needed it. I think the closest I've ever really gotten to cross compilation was Golang's WebAssembly compiler, which is a pretty cool piece of technology if you ever wanted to go down that rabbit hole. But anyway, so you have the default configuration, but then you have these useful options up here. Menu config is a so you have two different kinds of programs. You have your GUI programs, like you normally interact with, like it's got, you can point and click and do things, and it shows all sorts of different stuff. But then you have your console, which is text only. You can point and click inside of a console, but it's rarely supported. But generally it's text only. And so you have things called TUIs, where it will try and draw menus using text characters. Actually, here, let's just start it up. I didn't want to really break this, but is this going to break anything? Let's find out. There we go. So this is a TUI. It looks graphical, but I promise you, everything you're looking at inside of this box is text. These lines are actually like text characters you can type if you have an elaborate enough keyboard. And it provides a menu inside of a console. And so you can go through and configure all the knobs and dials for Linux. Like there's so many, they had to have submenus. And so like if you want to add include support for the JFS file system, which is just, don't worry about it. It just keeps going. I do plan on going through all of these settings, not today, but at some point. I want to know what they all are, what they all do, what the options are. Not necessarily so that I can highly optimize something, but just because, TUIs are always fun. Yeah, just it's good to know if you're working with like administrating Linux, what the options are, because it can reveal different things that the Linux kernel is doing internally just from its settings. If you're trying to, like, let's say you're trying to do something, you're trying to put Linux on an embedded system, but there's some feature that's missing. If you are familiar with the settings in the Linux kernel, you would know why that feature is missing without having to like spend a horrendous amount of time trying to figure out why it's available on one system but not another. And it was just because it was a different build configuration. It also lets you know what's possible in the Linux kernel, especially if you're working with embedded systems, or if you're working like if you ever get a job administrating a server and you have very specific performance requirements or some behavioral requirement of the system to support the application that you're hosting on the server. Thank you for posting the characters. That's awesome. It looks like the wrapping didn't quite work out. Oh, that's right. The chat overlay removes your ability to format or control wrapping, just so you don't blow all the text off the screen with a bunch of new lines. Yeah, sorry. But anyway, which reminds me, I should probably double check that chat on YouTube doesn't have like some Twitch. Yeah, some guy likes trains. Don't know if he's still watching. Yeah, sorry, I don't know what's going on with the chat overlay, but it looks like Discord is the only thing working right now. I gotta get into that tonight, tomorrow. Let me get back there. Okay. So Linux configuration. Oh, by the way, for all the new, like people who are very new to Linux, I appreciate that this is probably like very overwhelming. You don't really need to worry too much right now about like retaining any of this, just because I mean, this whole compiling of the Linux kernel is just more like, what do you do on day one? And this is the, outside of going through a bunch of really dry, high level concepts, I figured this is the most practical thing that I could demonstrate. So if you're just completely like lost, I guess your major takeaway is just know that this exists and that this process is a thing. I'm going to circle back around and explain this in much more detail later on. Bear with me. I'll get there, I promise. So anyways, the option that I went with is the default configuration to compile. So I went make default configuration. Whoops, daisies, I am accidentally typing into OBS. Like so. It automatically detects the architecture as x86 64. I had already run this command, so it's not actually making any changes. And then, so now you can go make all, which is described up here. So you can make all, which will compile all of the build targets with the star, VM Linux modules, whatnot. But I don't want, where did it go? Oh, it'll also compile a VZ image. Okay, I understand. So what it's doing is, okay, so first off, you want to make VZ image. This actually compiles the kernel itself. and its source code, and produces it doesn't produce the UKI like I described. The UKI is built up using a different process. This is going to produce a piece of the UKI that is the actual Linux image, like the actual Linux code, and then when I started Linux previously, I cheated a little bit using the emulator. The emulator has a feature in it that allows you to boot up just the Linux code and doesn't require the rest of the UEFI boot requirements. And I'm going to continue doing that just for now, because getting into the actual UKI construction is going to be a little bit more complicated. So make BZ image. Let's see, I've already compiled this, and because make is wonderful and won't recompile things that have already been compiled, this should go fairly quickly. Should. Worst case scenario, depending on your system, it can take up to an hour. Oh no, it can take a lot more than an hour, but I believe it took about an hour to compile on my system. The Linux kernel. There's a lot of code that it has to go through. And I'm really hoping this doesn't take terribly long. I might actually just cancel it. I am going to sneeze. Excuse me for 1 second. And of course, the mute button double tapped. Sorry about that. This is taking forever. I was just kind of like show off. Like I was hoping that it would just show off all the make targets that it hits in between, but I don't know if I want to wait for this. If you're following along, I recommend you do. It's just a really healthy exercise just to like compile stuff, just so you know all of the different inner workings. Assuming you're programming. If you're, once again, very new to the whole Linux space, you do not need to understand this. Yep, I'm canceling this, never mind. So anyways, so that will produce a BC image at, where did so under the Linux Arch x86 BZ image path. Now when it does successfully compile, it actually tells you where the file output was. And with all the default settings, it looks like the kernel is 14 megabytes, which I'm a bit surprised, because this actually compiles all of the kernel drivers directly into the kernel rather than leaving them as separate modules. There are still some modules that are left separate, and they should be compiled as well. So normally you would go make modules just to clean up the last bit of the build. Module. Not module. Oh, once again, I am not inside the Linux directory. Make module. I don't know why I bothered actually executing that command. It's probably going to take a hot second as well. Yeah, forget it. They've been made. Don't worry, they're there. I did it before. And now you have your BZ image. One thing I want to point out about the BZ image, which I actually just figured out myself, because I was wondering why BZ image. Normally it's called VM Linux on the boot partition that I had mentioned previously. And then BZ image, it looks like once it produces the VM Linux file, it turns around and bzips it. I didn't know that actually was a thing. Makes sense. Didn't know it was a thing. Bzip is just a variant of a zip file, so it compresses it. Although zip files are a little bit different. And then we circle back around to now that we have this, we use the Linux directory. I'll forget about this again. So cat is one of the commands provided by core utils and toybox, and all it does is takes a file and writes it to its output. And I've produced a file called run. So run is just a little script that has helped me remember all of the arguments for the QEMU computer emulation program. But it also, the script resets the console because this program corrupts my console every time it runs for some reason. So we pass the BZ image to this to start up the computer, the virtual computer, and boot the BZ image. Append console, that's just something that needs to happen that tells this program to actually take the output of the boot. Discord chats. Give me a second here. I'm just gonna try and pop out all these chats and just forget because I keep missing messages. How do I pop you out? Yeah, man. I'm equally frustrated because this was working perfectly when I was testing it. I have a whole set of tests for this chat overlay when I wrote it. Second it touches reality though, and apparently you can't pop out the chat in Discord. I don't know. Here we go, pop out. Nope. I mean, you can pop out the whole stream in Discord, but I just want all video or all chat. Anyways, I'll put that over here. Where's my YouTube chat? Make sure I'm not ignoring people over on YouTube. Wrong YouTube. Oh, the chat's working here. I don't know. I'll just go with this anyways. And I lost where I was. Anyways. Yeah. You currently in YouTube and Twitch. How's Twitch doing? Three viewers. Looks like I haven't missed anything in Twitch chat other than someone likes trains. Okay, I'm just going to go back to this and carry on. I guess at this point, it'd be good to just kind of stop and be like, any questions? I have been racing through a lot of stuff. What am I looking at here? We have the Linux kernel built at this point. I had previously demonstrated that it runs, although it will panic unless you provide it some sort of disk or initial program. I should mention, so there's a line in Linux that will come up constantly. Oh, come on. What's happening? There we go. And it's called kernel space and user space. Where are you? OBS. Let's get a whiteboard out. See what happens. Let's talk about kernel space for half a second. Well, that was the straightest line I've ever drawn. Better. So you have kernel space. Oof. I just tried the stylus for the first time and I did not like it. Kernel space, user space. Nothing in, so kernel space is basically the memory space that the kernel runs in. It is protected. Nothing but the kernel and kernel modules can access it. These are drivers. These are different things that provide functionality, whatnot. It has max, like in terms of security, I don't want to say there's no security in the kernel space, but basically everything has more or less access to everything. I just realized my camera is not on the whiteboard. Give me half a second. Copy, whiteboard, paste, camera. There we go. So yeah, like I was saying, kernel space, everything it's like the highest privilege. Basically, if something's running in kernel space, it is completely trusted on your system. It can access all of your files. It can see everything you're doing. Yeah. And makes sense to have chat. In user space, all chatters are insecure. Chatters are more than locked in user space. They are in their own little chat space. Oh, I see what you mean, the overlay. That's even funnier. Thank you. So everything's trusted. If it's running in kernel space, it's completely trusted. It has access to everything. More or less, there are, if you really get into it, there are some barriers inside kernel space between the different modules, but everything's trusted. And so I don't know if anyone has heard of the CloudStrike issue that brought down like a huge number of computers. The security company that is responsible for monitoring, they provide a service to, it's kind of like an antivirus that runs on commercial computers. These include like billboards, TVs in like, if you go into like public transit, you see TVs. They've got, I don't know if they were in ATMs, but they were just like this. It's a commercial offering for business computer hardware to be monitored and ensure the security. And one of the things they did is they wrote a kernel module in and had it run in, of course, in kernel space. And they pushed a change that blew up and took out every computer that they had that kernel module running on. And because it was running in kernel space, there was no way for the computer to recover. And it required people to go and manually fix every single one of these computers that they had pushed this change from. Probably a little bit more accessible example is kernel level anti-cheat for video games. I think Valorant or something, one of those competitive games requires running a kernel module in kernel space that monitors your computer, that makes sure you're not running any cheat programs. This is on Windows. I don't think they have one for Linux yet. Windows, to just clarify, yeah, kernel level anti-cheat is terrible. It's one of the major barriers actually to running some video games on Linux is the kernel level anti-cheat they only have available for the Windows kernel. But it's problematic because it means that you have this like random company who's running software in your highest trusted level with no restrictions. They can do whatever they want, and they can push changes to this software whenever they want. There's just nothing restricting them on your computer. They can see what you're typing. They can undoubtedly like access cameras. It's crazy. Generally, you don't want that. And I'm pretty sure the Linux project is opposed to ever putting anything like that in the Linux kernel. That said, you can write kernel modules that are not included with the kernel, like I previously mentioned. But anyways, that's kernel space. Maximum trust, it's where all the code runs that accesses the hardware directly. So your drivers, your network stack, which is everything that handles like internet access and like all of that. Just everything related to do with like keeping your computer running and functional is run in kernel space. And then on the other side, you have user space. And the line for this occurs, like I mentioned, you saw the kernel start up and print out all of its things about how it's initializing the system. And then it jumps into that run script I had, or the Toybox shell that it gave me. I should probably pull that back up just to illustrate. Just to get back there. So in this instance, it failed to find that. But at this point, the execution is moving from kernel space into user space when it executes the init program, the initial program. So in my case, what I have is, so that init ramfs cpio file that I have, that I keep mentioning, is like the initial disk that it's loading to find the programs, that the Linux kernel loads to find the programs. Let me get rid of this tablet. In this case, so you have the init ramfs, which is a special little file that the Linux kernel specifically knows how to work with, that doesn't require any separate disks. It just pulls it up off the boot disk, and then it unpacks it in memory. Just to be clear, a CPIO file, it's a zip file. It's just like you have bzip. CPIO is just, actually, that's not entirely correct. For the truly layman's, it's a zip file. In that you take a bunch of files, you zip them together into a single file, and you get a zip file. In the Linux world, the closest comparison is a tar file. Zip files are compressed generally. Tarball files are a collection of files that are put together into a single file, but it's not necessarily compressed. You can get a tar file that is then compressed into using gzip or bzip or whatever at that point, but CPIO files are not compressed, just like tar files are not compressed unless you compress them with a separate program. So a CPIO file is just a collection of files that have been packed all together into a single file. And then that single file is handed to the kernel and it unpacks it into memory when you boot up your computer. You make this CPIO file, unsurprisingly, using the CPIO program. It works just like a tar. It works just like tar. It's if you've heard of tar, it's very similar. Wow, that's a lot more help than I was expecting. It's it's produced by New. These guys, like, you're going to see this everywhere in Linux. These guys produce not all, but like a lot of the core programs that you'll find on the command line in Linux. Um, and like a tar file, the CPIO program has a bit of a strange interface that requires you to like send it a list of files to include. It's kind of clunky. I actually would prefer tar files. There was a big debate in the Linux, I don't know how big of a debate in the Linux community about whether or not they should use CPIO files or tar files support for the init ramfs. But CPIO is a bit simpler, and it's easy. The code, it requires very little code to work with a CPIO file, and so they stuck with it because they're like, why would we change when this works? And there's no real motivation to switch to a tar file. So we have CPIO, although I kind of hate the CPIO utility. Just its interface is awkward. Because its interface is awkward. Oh, is that what it is? Okay. CPIO is designed for sequential media like tapes, which is also part of the backwards compatibility thing with Linux. But are you sure? Isn't tar is sequential too, though? It doesn't require random access to, like, you can concat. So one of the things about CPIO files is you can take two CPIO files and just concatenate them together, and it still works. And I'm pretty sure you can do the exact same thing with tar files. Am I wrong? Yeah, I don't know if chat's lagging out there. I'm not. Oh, okay, I'm not wrong. But yeah. Anyway, if you're familiar with tar files, you're familiar with CPIO files. It's just a different standard. There's nothing. There's nothing really meaningfully different between them on the surface level. So I wrote a little script that helps me deal with the awkwardness of the CPIO utility with all of the arguments. But basically all it does is I have some files in a folder called root. I called it root because it is the everything inside this folder is the basis for what gets booted up in the Linux kernel. And in root, I have two files. I have Toybox, which, like I mentioned, is a re-implementation of all of these little like console commands like ls and all of the commands that I've been using, like cat, and also it includes things for like managing your network. Basically all of the base utilities that you need to manage a Linux system. And it packs them all into a single executable, which is convenient. If you look at core utils, which is oh, that was surprising. Really? Who provides bash? Bash provides bash. Of course, bash provides bash. What about cat? Oh, I wasn't expecting this dash from utils thing. Is that a Debian thing? I don't know what's up with that. Anyways, core utils. All of these little utilities that I've been using, they're separate programs. Like if you look at user bin, just like a bajillion little programs, not ideal to copy around. The other problem is these have other files they're dependent on, and you need to copy those as well to run. I didn't want to do that. Toybox makes that very simple. You only need the one file, and it works. I mean, I can even like I just downloaded the Toybox program from Toybox. So that's landlead.net/Toybox. And the big thing about Toybox is it's BSD licensed, which makes it pretty much, you can just copy it and distribute it wherever you want. There's nothing, there's no real restrictions, there's no commercial restrictions, unlike its counterpart, BusyBox, which you may have encountered in like, if you work with like Alpine Linux or something like that. And you can compile it if you're yourself if you want, or you can just, that's not what I wanted, or you can just download the binaries directly off of their website. I had a download link right on their main website too. I don't know what happened to that. 0813. Oh yeah, static binaries. So you can just download that, and it'll just give you the Toybox file. Yeah, Toybox. And it just works. There's no extra. So normally programs, when you install them, they need a whole bunch of files, like I mentioned, shotgun throughout the system, shared libraries mostly. This is called statically linked, which means everything that this program needs to run is built inside of it, this one file. And it just works everywhere on an x86 system. So I include that in the root so that it works, so that I can execute commands. If that Toybox program wasn't there, there would be no, well, let me get to that. So with the Toybox program, I also created a script. Like I'd been showing before, I have these little scripts that help with things. I have this init script that, very simple. It does just some basic, incredibly basic initialization of the system, which is basically just creating a bin folder when it starts up. And this line right here has to do with the way Toybox works. Because Toybox contains all of these different programs, you kind of have to create aliases, is probably the most high-level way of describing it. Otherwise, you always have to like, so in the like, so let's say Toybox, let's say I want to run the cat program that Toybox provides. I would have to run Toybox cat, and that just catted the init file I had beside it. Running Toybox before everything, every command, every single time, really annoying. So what this does is this makes aliases that just makes it so that I can just type cat and that works, but it actually calls the Toybox program. And then once it does that, it tells, this is getting into a little bit more detail than needed, but it tells the system where to find all these programs when I type the command. And then the key line here is Toybox provides a init program that that tells the shell program, the thing that actually lets me type stuff. This is the shell program. It hooks it up properly to the console output of the virtual machine, which is actually, let me demonstrate that for everybody. So remember how we were talking about teletypes, and I hope I'm not, I've noticed that this thing is waiting for messages, and I hope I'm not missing out on chat. It doesn't look like it. Okay. So just a little detail about this emulator. and I'm going to explain this console TTY. Oh, is it corrupt again? Yes, it is. Yeah, I don't need that. Actually, I don't need. Anyways, so I've been telling it no graphic, which basically means that I'm telling the emulator to pretend that it's hooked up to a TTY device, like a teletype or a printer, or in my case, where it just sends raw text rather than drawing a GUI or like putting something on a monitor, and it sends that text out a virtual serial port, which is for the like a USB port is a universal serial port. There's much more simpler versions of that where like on a USB you can plug in like a variety of different hardware with a variety of different functionalities, and it can communicate to the computer through all of the magic of USB. But before that, there were just plain serial ports. If you work with like Arduinos or it sends one thing at a time. Yeah. So if you worked with like microcontrollers, you've encountered UART serial ports. You've encountered like even just writing programs to the device, you have to use the serial port, and it's basically it's just a port that all it does is essentially sends text, and that's all it does. You can think about it sends binary, but you can think about it as like just a single stream of text that it sends, and it can receive as well. And so I'm basically telling the Linux kernel and the emulator here to send all of its output to that serial port, virtual serial port, and all of the output gets sent to my this program right here, this black box that I keep typing into. The program itself receives the data from that serial port and writes it out on my screen. And then anything I type into it sends it back. The alternative to that is if you want to actually interact with like a virtual monitor, like a virtual computer screen. And you do that by like removing the no graphic thing, and that will open up a virtual computer screen. Can I zoom on this? Yes, I can. Whoops, Now, I generally don't want to use a virtual computer screen because if I want to copy and paste text out of this, this is an image. Yeah, there's like, I know it looks like it's like you could potentially copy and paste stuff, but it's an image. You can't copy and paste out of it. So it's kind of a pain in the butt to work with. Once I get into like in the process of building out a Linux distribution, at some point I'm going to want to get the graphical stuff working, which is when I would switch to this. But it's we're not there yet, and so I don't want to have to. Oh, come on. Control G. It grabbed my input. Serial 0. So this is. Can I actually? Oh, I just learned something. Apparently, QEMU provides effectively the same thing as what I was doing here. Know that? Is that useful? That means that I'm always switching between here and here when I'm doing stuff. I don't know if that's useful. Yeah. Anyways. So I lost my train of thought a tiny bit here. We are talking about the init process. So uh, anyways, this whole mess and this whole mess basically just tells this program to, this program to send all of its input and output through that virtual serial port so that I can access it outside of the virtual computer that I'm running the Linux kernel in. Now this gets me to the point that I can run, no, not cat run. What's happening here? There we go. No, not you. Yes, you. So that script I'd shown those before. Oh, sorry, let me back up a bit. We were looking at the make CPIO. So this script just takes everything in root, the root folder that I mentioned, toybox, and the init script, and packs it into that init rdcpio file, preparing it for the kernel to load up. That was the bit I wanted to include. And then we hand that off to the virtual machine, is the emulator. This is the bit of the cheat I was talking about. Normally you have to copy the kernel, like I said, to a boot, a section on a disk that is labeled for boot, with a whole bunch of extra things so that the firmware can find it and get the whole process going. This guy lets me cheat a bit, so I don't have to do that, where I just tell it, hey, here's the kernel, hey, here's the initial file system, fill in the gaps for me. And that's exactly what it does. So I just rebuild the make the CPIO every time I run it, just so I don't have to think about that, and then fire off the virtual machine, telling this is a parameter for the Linux kernel that tells it what it needs to look for, where it needs to look for that initial program that it tries to start. And I haven't forgotten that I'm circling back around to user space. We're going to get there right now. So it's still in kernel space right now, loading up everything that it needs, getting all the hardware copacetic, and then once it gets everything ready, then it looks for that initial program and runs it, but it runs it in user space. So actually, does this work on? Yeah. So the init script that I'd mentioned is the first thing that it runs, and this script doesn't stop running so long, or for as long as the computer is on. If this script were to exit, the kernel would panic again. I can actually make that happen. There's unfortunately a little flaw in my script here where if any program exits with an error, it will accept that. Let's grep nothing. Yeah, the script exits and the kernel panics because it's not supposed to exit. Let's get back in there. So like I was saying, so the init program, when it starts, it should not stop ever while the computer is running. It is responsible for, at some point, generally is responsible at some point for shutting off the computer. My script does not handle that at all, which is why it panics. But that initial script, yeah, like I keep saying, stays running, and then from it, it launches other programs, and it's responsible for. My script obviously doesn't, but it's responsible for setting up the rest of the system, getting it ready to, like if it's a desktop computer, loads everything up, gets it running, and then it eventually shows you a login screen. And it's just like this cascade of programs that get started up to do different things in user space. This is all happening in user space. And eventually get your login screen or whatever the state that the computer eventually wants to be into. If it's a server, then it's launching services and stuff like that. But for the most part, we care about desktop computers in this stream. Okay, whiteboard. So, did I just get? No, I didn't. Okay. Like I said, what's happening? Oh, that's why. Come on, GIMP. There we go. Like I said, kernel space is the highest privilege. User space cannot access kernel space in any way except one way. The user space programs that will... A user space program is pretty useless unless it can talk to the kernel. Like a user space program can't do anything on its own. If it wants to read a file, it has to ask the kernel to do it for it. If it wants to oh yeah. So this program I have right here, GIMP, is also produced by New. They got their hands on everything. It's pretty nice. It's the alternative to Photoshop for Linux. There are alternatives out there that are paid. This one's free. I know my wife uses one that's actually really nice for illustrations. I can't remember the name of it. But anyways, any program running in user space has to go through the kernel, has to ask the kernel to do anything. A program running in user space can do anything within itself, like math or like something. Basically, if a program wants any sort of input or output or to interact with the outside of itself in any way, it has to do it through the kernel. And the way it does that, there's only one way to interact with the kernel. Yeah, thank you. Memory management, malloc is still a kernel request, isn't it? Or is that? I honestly don't know what I'm talking about there. Oh, okay. So yeah, and there's moving stuff around. Oh yeah. That can be done in inside the program. The only way this can do this is there is and this is actually a computer code instruction. I learned this recently. I wasn't entirely sure if it's... I'm gonna break the suspense here. It's called... is that... Oh, wow, that is not legible. And my... Where's the hardness? Oops, I went the wrong way with that. Okay, we're getting there. Of course. This is something I need to improve for the next stream as well. There we go. Helps if I'm pressing tab instead of caps lock. Okay, let's try this again. I really should have made that eraser bigger. Going over here. I'm about to throw this out the window and just start using my mouse. It is very hard to write with my mouse though. Anyway, writing with my mouse. Sorry for the legibility. This tablet is syscall. It is the only way for a program to interact with the kernel and to interact with the outside world, because the program has to ask the kernel to do things for it. This reading files, allocating memory, like literally any sort of user input, events, syscall. A program can receive some inputs from signals, but let's not worry about that just yet. From syscall, they have another layer of a few layers of this is called mom help. Yeah, pretty much. There are some layers built on top of that. You have file operations, so open, write, read, whatever. That works with files on the disk. You have something called I/O control for manipulating things like serial devices. And you have, I think, I don't know if this quite fits in the category, but you can, there's a shared memory that you can get the kernel to allocate for you between processes and itself. And then there's sockets, which is a big one. A lot of things within the kernel are interacted through sockets. And you open a socket. A socket is like opening a connection to a web server or something like that. But instead of a web server, it's the kernel. But it's not TCP protocol or anything like that. So the point of that, what I'm getting at with all of this, is we have syscall is a architecture, or is a system, like a CPU instruction. It's actually part of the x86 standard. I learned this recently. I thought that was really interesting because I'm surprised they had such a high level instruction built into the hardware. Like, this is an operating system thing between the program and the kernel, but it's built actually into the chip. And this is available across x86, ARM, whatnot. I'm sure they call it something different on some weird esoteric hardware. Kernel mode itself is something else I was also trying to figure out, is when you do a syscall, it doesn't send something to the kernel. It actually starts running kernel code as part of the program. So this is getting a little bit complicated, but you have your like execution pointer that's like pointing at the line of code that it's currently executing. And when you do a syscall, it takes that execution pointer and interrupt. I thought it moved the execution pointer into the kernel's program space. And that's the whole point of there's a shared library that Linux produces that allows it to do some operations in user space without having to move the execution pointer into the kernel space. Oh, okay. Fires an interrupt. I guess, yeah, it interrupts the program execution, moves it over to the kernel, starts running kernel code in the process of the application that you're running, and then once that's done its thing, it moves back. I think I'm not an architecture person. Anyways, I'm going somewhere with this on a much simpler level. So what we have is, because because syscall is a assembly instruction, a computer instruction, it's built into the program. You don't need to do anything special to get a program to be able to talk to the kernel via syscall. And there's a lot of functionality that syscall provides, like I said, reading and writing files, opening sockets, I/O control. There's like, I think, hundreds of different things that syscall can do that are higher level interfaces. But in order for, let's say we're talking about opening files, in order to open a file, you need to be able to provide a file path, which sounds like a stupid thing to say, but if we go back to, it's funny how that takes a second for the VM to pop up. Hello, David Computer, please and thank you. Come on, don't do this to me. Stop streaming, start streaming. Thank you, OBS. So we have this super basic command line that we booted into the Linux kernel. We're now in user space. We have Toybox set up so that we can run little commands. Toybox has built into it all of the necessary syscalls so that you can do things like ask the kernel to list off all the programs in the current directory. Programs generally have what's called the current working directory associated with them. So in this case, this shell that I'm in right now has a current working directory that I can change using the change directory command. So I can change directory to bin and then list all the files in the current directory, which is in bin. This is all the programs that Toybox provides. Just to re-illustrate, remember how I was talking about how it's aliases? So all of these are aliases that point at the Toybox program. Unless you're using Toybox or VisiBox, you probably don't really ever have to worry about that. Core utils, each one of these is a separate file rather than an alias. And so you're like, okay, great, I got a full working computer right now. So remember how I called that folder root that I was loading Toybox and the init script into? So this right here, the Linux file system is in a tree structure. So you have the root folder, which is represented by this slash, and then everything under that. So you have like the bin folder within the root folder. And generally, not talking about containers, there's one root folder for the system when it starts up, and all files, everything is under that. But right now we only have bin, which my init script created, if you remember. made the bin directory before creating all those aliases. Dev was created by the Linux kernel itself as it was preparing to move into user space. And it did that because it needs to put down this special kind of file called character device. Remember how I was talking about the console, dev console? This Linux represents different resources in different ways depending on what we're talking about. A lot of hardware, if you want to directly interact with hardware from user space, that is done through these special kinds of files. Like if you want to refer to the hardware, you want to say, hey, Linux, I want to do this thing to this hardware. One of the ways Linux allows you to say this hardware is by creating a special file that points at the hardware. And there's nothing in the file. It's a pointer to the hardware. This console file is a pointer to the serial device that I'm connected to, the virtual serial device I was talking about before. And so I can read and write to this file. Let's see if I can corrupt this. So I'm going to echo hello. So echo, it just takes the text that I provide it and outputs it on its output. Standard output is what it's called. And this little symbol right here is telling it to output it to dev console, and it sent it through the serial port to this program right here. I know it kind of almost looks exactly the same as just writing echo hello, but I promise you, this is echoing within the shell. This is just writing it to the screen within the virtual machine, whereas writing it to dev console sent it out the serial port, skipping the virtual machine, skipping writing it to the virtual machine, and wrote it directly to my terminal program. And Linux needs to drop this file down in order for the shell, the initial script file, to be able to connect to it and allow me to type and see what's going on after it enters user space. So that's one way the Linux kernel exposes access to things. And then you have sockets as well. So like I mentioned, there's a special kind of socket that you can open, which is a connection, like I said, to some service, be it on the internet or the Linux kernel itself has some sort of service. One of those services is the configuration for the network hardware. So the program that manages network hardware within Toybox, there's a much better program that is available these days that's provided for managing hardware. It's called IP. ifconfig is the old version of it. Toybox is working on implementing the newer one, but they haven't done it yet. So I just tried to get the ifconfig program to show me the current configuration of the network card that gives the computer access to the internet. And it came back complaining, no file, procnet dev. So ifconfig is a user space program. It can only ask the kernel to do stuff for it through the syscalls, like I mentioned, and it can't directly access the network hardware or the network stack within the kernel. So like I said, interfaces are built on top of syscall, like reading and writing files. So this program interacts with a special file called dev within the net folder under the proc folder. And that's how it accesses the hardware. it tries to open this file and write to it and read from it. And then when the kernel sees it trying to open this file, it says, oh, that's a special file. So anything that's read and written to this, we're going to ship off over to the network system inside of kernel space. And they interact that way. The problem is this file doesn't exist. And I'm bringing this up because there's a big difference between booting into a shell in a Linux from the Linux kernel and having a functioning system. There's a lot of things that need to be put in place before user space programs have everything they need to work. One of them is a special. So you have this concept of file systems. It's like a driver that gives you. So you need to differentiate. So you have block devices and then you have file systems. They're separate things. Unfortunately, trying to keep this simple, this is going to get a bit confused. A file system is, well, okay, like for the example, the init, the CPIO file got unpacked into a RAM file system. And it's just a system that organizes files and gives them properties. So like if you look at these files, they have like, when they were modified, permissions, and a bunch of other properties that I'm not going to get into. And all of this is tracked by this driver. So this is the RAM file system that Linux kicks off on boot, but there are more types of file systems. Probably one of the most common ones is, it's called the FAT file system. It's used on a lot of USB devices. Like if you have a USB thumb drive, all of those files on that drive are organized using the FAT file system. That boot partition, the section of the hard drive that's supposed to contain the UKI or the Windows like kernel or initial boot file, is also a FAT file system. Yeah, file allocation table. There's other variations. Some of these file systems are built to manage files. That sounds like a stupid thing to say, but you have like your thumb drive. You want to just be able to copy and paste like files in and out of the thing, and those files are files you came up with that were created by some other program, like PDFs or images, and just arbitrary files. But you have other file systems, and the file system determines how it's actually physically laid out on the USB stick. There's different ways of doing it with different benefits. There's like the file allocation table, the FAT file system, very basic. It just drops the files down, doesn't really try to do much with them. You have other ones where it will store some extra information that will make it so that the file is harder to corrupt. Like, I don't know if you've ever used a really crappy USB thumb drive where you copy a file to it and then copy a file out and it's no longer any good. It was corrupted. You can get, we're kind of getting into the block device space talking about this, but you can get file systems that help prevent that by storing extra information that prevents the corruption. You get file systems that do all sorts of like, you can get file systems where the data is stored like in the cloud or something, but it's made available as if it's on your computer. And the driver for the file system manages that. And then you have these special file systems that don't actually store files in the sense that you're used to. They are ways for the kernel and kernel modules to expose configuration and internal bits of itself to user space. One of these is the procfs, or proc file system. And this driver or file system, I keep doing air quotes a lot, but man, it's like we're getting abstract here. And hand wavy, because you could like actually me on a lot of this stuff, but I'm trying to keep it accessible. The proc file system is it's a file system that it lays out a bunch of files that a process or a program can look at to see information about itself, for the most part, information about itself from the kernel's perspective. So like how much memory it's currently allocated, or just lots of little details. Excuse me. Hopefully I got the mute button right that time. And it also exposes access to, like we saw here. So proc is almost always, it's actually part of the standard. It's located under the proc folder on the root in just about any POSIX file system, or POSIX file system layout. So the proc driver creates a folder called net within itself, within it where, let me back up a second here. Oh, I haven't pushed that yet. Fun. Okay, so we're going to get into file system mounting. So one thing you can do from user space is, well, first thing we're going to do is we are going to run the program that asks the kernel to create a couple of empty folders. I just created two different folders, the sys folder and the proc folder on the root. And then we are going to do another system call called mount. And this mount system call tells the system to load a file system driver and basically take over. So if I here, let's do this. I'm going to create a file in proc touch proc hi. So now there's a file in that folder called hi. And then the mount command, what it's going to do is it tells the kernel to load a driver, a file system driver, and that file system driver is called proc. And the file system type, once again, proc in this specific case. And I want it to take over the folder proc. And when it takes over that folder, it basically hides the original folder that I just created and overlays a bunch of virtual folders or files inside of it. So now I can go, so these are all the files inside proc. A lot of the files are, or a lot of these are actually folders, but some of them are numbers, some of them have names, lots of stuff. None of these are actual files. Excuse me. None of these are actual files. Like you can't delete them. You can't really move them. You can kind of copy them depending on the file, but it's not like a file that you're normally used to seeing. The oh yeah, have a good day. Thanks for dropping in. What is it? 8:30. It's been 3 hours. I think I'm gonna go for maybe one more hour. We'll see. We'll see what happens here, and we'll go from there. So once again, these files they're not real, as in they're not files that you're used to working with, and that they store like some document that you can like delete or move around or whatever. These disappear as soon as the computer reboots, and when you remount the proc driver, it kind of recreates them. And each one of these files in here represents some information inside the kernel that you can now access using the system call to open a file and read and write that file. So this is one of the mechanisms, like I was saying, that you can interact with the kernel, that you can cross that boundary from user space into kernel space. Each of these files, of course, has file permissions, so not everyone on the system. Yeah, it's owned by root. Unfortunately, that's not set up yet, so it's hard to read. And you can see yeah, lots of different things for lots of different purposes. So now that we have, just to demonstrate, I want to double down on that the hi file doesn't exist within the folder anymore because the folder was taken over by the driver. It wasn't deleted though. So I can actually unmount proc. Oh, whoops. I don't know why I did that. So I just told the driver to remove itself from the system and not take over that folder anymore. And right, I think I have a user ID of 1,000. No, I don't. It should be root. I don't think. Interesting. Oh, user ls. This is where I'm running into my limitations in the understanding of Toybox. Toybox doesn't have sudo, it has su, but su wants a user. Can I just su 0? No, because that's not a real user. Something weird happened with the proc folder. The permissions changed, and I can't list it anymore. Can I chown? Oh, yeah. So the permissions got changed. I'm not entirely clear. It got changed to user 2. Is that what happened? No. User and group 0. Not entirely sure what happened there. Something probably became inconsistent. Generally, you don't unmount proc. It would, on a full system, it would probably crash out the system pretty quickly, just because of everything's like, actually it wouldn't even crash out the system, it wouldn't let you, because things are reading and writing out of proc all the time. But as I've demonstrated, the hi file still exists inside of the original proc folder that I created. That's not really useful. You would never really mount over a folder like that, at least in this situation. There are, I guess, times that could be useful, but they would be really specific. Anyways, let's get back to mount t proc proc to proc. Proc is short for procedure, by the way, like or process. I mean, like when you run an application, it's a process in your computer. But now that proc is mounted, we should see proc /net / whoops, is it dev? Net. Oh, and ifconfig is happy because it's able to access that file inside of the proc file system. I just want to find the path that it was failing to access to actually demonstrate it was. Okay, it was procnet dev. So I can ls procnet dev, and it exists. Okay. So now that it exists, I can run the ifconfig command, which then goes and opens that file and reads from it and gets this information, which is the current configuration of the network devices. And we're not going to set up the network today. There's a bit of extra stuff that needs to be done there. Today, we're just going to focus on getting the system a little bit more functional. There is basically two mandatory Twitch. I'm just checking on chat, making sure I don't trust my chat. I'm getting all the messages, and I'm not. Okay, chat's still good. So there's two different systems. You have proc that exposes process specific stuff plus some extras. It's kind of disorganized. It's an older system that's still in use. They still use it. It's included with the Linux code base. And then you have another one called sysfs. And sys, I believe, is how I want to do that. So within this the sysfs driver provides a lot of internals for hardware for the, like it exposes a lot of hardware configuration from the kernel. So it organizes them in folders, depending on the bus or the class of hardware device. There's like, oops, that was not what I wanted to do. Sys dev. So you have different types of devices. We have block and character devices. Firmware you can access. You can access kernel information. Like all sorts of different things. Lots of very like specific things that you'd have to be interested in to really look at closely. But this allows programs in user space to query different properties of your hardware and manipulate them. I think if I were to write a 1, like if I were to go echo 1 to sys kernel, oops, tab completion kernel. But I think if I did this right now, it would reboot the system. But I don't want to do that. But I'm just trying to illustrate how you would utilize this. So this is an interface that is provided that allows you to read and write bit as if things are files. Linux leans really heavily into organizing things as files. They departed a bit when they started using sockets for stuff. So now that we have the proc and sysfs mounted, those are the two main things that are needed to make most applications happy. If we look at my actual development system right here, there's a lot of different types of mounts depending on that are being used, that represent like a more complete system. You have, I'm actually a little surprised this is here. That shouldn't be 10 pfs. UDIF on div type. Yeah, I'm not entirely sure why that's there. I'm just going to skip over that. That's odd. Yeah, just different drivers. Temporary stuff. So this just stores it in memory in kind of a low priority so that when you reboot, it just gets wiped. There's a security FS driver for accessing security settings and information. C groups, just different systems that are available for more advanced things. You've got, what's something that's interesting? The one that's going to probably be coming up pretty quick. Oh, it's not mounted here. Is UEFI VARFS. Is it really not mounted here? Interesting. Anyways, that file system driver exposes, like I mentioned, the hardware, the motherboard of your computer has firmware inside of it, and that firmware is generally referred to as your UEFI. You may have heard of your BIOS. That's an older way. It's not a variation of UEFI. It's a completely different implementation of your computer's firmware. UEFI is much more modern and modular, whereas a BIOS is very opinionated, rigid, less robust. So yeah, UEFI VARFS exposes the UEFI firmware settings to user space, so that from user space you can configure your firmware. And one of the key bits of that is configuring. So if you want to dual boot Windows and Linux, you will need to create two UEFI variables for the two different boot options, Windows and Linux, using UEFI VARFS. And then, but we don't need that right now for this. So from here, everything that I just did was a very manual process to get it to this point. I had to mount things, I had to create folders. It's still not complete. There's a lot of other stuff that has to happen. We still don't have any sort of GUI. There's nothing in here for like graphics drivers. There's no like sound, Wi-Fi configuration, Bluetooth configuration. There's all of these different systems that need to be supported from user space applications, and they're not there. And so that's what I'm going to be getting into adding in later sessions. I think the next step is to get rid of Toybox. Toybox was fun for playing around, but it is not really what we need for a more complete desktop environment. The next thing I think we have is coming up is like new. The new organization produces a lot of command line utilities for working with Linux, the Linux kernel, and providing a useful environment. There's another organization called Free Desktop. Free Desktop provides a suite of programs that user space programs that are responsible, that do everything I just described. They provide, and not to say that GNU doesn't provide utilities like this, that GNU also does provide an alternative. It's a bit older. It's a bit. I don't want to disparage it. It is still used in some modern Linux distributions, but the free desktop provides something called systemd. It's a suite of services that get started up. They provide an init service. They provide a network management service. They provide a bunch of things that are much more robust. They interoperate really well, and they provide more management functionality in terms of you can configure them. You don't have to use the command line to configure them necessarily. They provide more opportunities for GUI configuration. And that's not to say that alternatives don't. It's just that they specifically are built to be manageable via a technology called dbus, which is a standard way for programs to talk to each other. So yeah, I'm going to be probably in the next session downloading and compiling systemd. It gets pretty interesting from there on out because you pretty quickly start to get a more complete system that you can actually start doing things with. From there, I'll probably be going with KDE, although I still need to figure out the boundary between the core system and the containers that provide a more complete, provide the actual desktop environment. Yeah, I have a pretty good sense of where I want to draw these lines, but there's some details that are going to need to be worked out through the process. I think this is probably a good place to cut this off today. I hope everyone watching this got something out of it. If there was anything I forgot to circle back around on and explain, let me know. Check my channel information for links to different places. Discord has a Q&A room that you can post questions in. I'm happy to answer them. Yeah, have a good evening.